Okay, everybody, welcome to this quickie, they call it. It's going to be about service discovery in microservice architecture. And please welcome Magnus Larson for this talk.
So I want to share some experiences in the presentation. Microphone.
Should be on.
Hello, 1, 2. Is it better? Okay, let's try again. Now I can hear myself actually. So within this presentation, I want to share some experiences from using different types of discovery services while helping customers to start develop microservices. I only have 50 minutes, so I'll skip all type of introductory material and skip directly to the key questions asked by customers. And there are basically two types, and they are both about how to deploy microservices. One type of customers are not so sure about containers yet, whether they are mature enough, so they want to start to develop microservices, but maybe not right now deploy them to containers, but probably in the future. So the question is, how will the code that we write now be affected once we migrate into container world? Another group, they want to go into container world, but they are unsure of what a container orchestration tool to use. So if they pick one now and later decide to move over to another orchestration tool, how will that affect the code in the microservices? So based on these two types of questions, I gave myself a task or a quest last year to really try to dig down into the details and to understand whether it's possible and how it's possible to write microservices that can be moved between different environments without changing their code. Basically only require changing of their configuration. And based on interest of customers, I selected these environments or platforms. First, deploying without containers using Netflix Eureka as a discovery service. And then in container worlds, I selected 3 orchestration tools with their embedded service discovery functions. Google Kubernetes, Docker in swarm mode, and Amazon's EC2 container services. And it was quite obvious from the beginning that the main challenge to be able to do this is based on understanding of how the different service discovery functions worked in the different platforms. So I now would like to go through each of these environments and say something very briefly about each mechanism. So warming up without containers, then we have discovery service based on Netflix Eureka. So I developed a sample microservice that can produce quotes on request, and a web application that can request quotes from the quote services. And then I connected them to discovery services. And I run some basic tests, verifying that load balancing works when the portal submit request to the existing to the quote services that are up and running for the moment. And then I started to kill quote services instances and even discovery server instances, and ensure that no errors appeared in the web application. And then I started them again and ensured that they came back and started to take requests without affecting the web application. So it works, and I mean, Netflix software had worked for many, many years, so no big surprise there. Over to the container world and orchestration world. First, Docker in swarm mode. It came half a year ago in Docker 1.12, so it's rather new software actually. And here's a sample of a cluster of nodes. Some nodes are masters running the orchestrator, and then we have a number of worker nodes where the orchestrator launches container instances. And there's also a concept of services, Docker services. And there is a component in each worker node, the load balancer, that is responsible for this service concept. So when you create a service, maybe I have it here, Docker Swarm will allocate a static IP address for that service, and that service will have that IP address for the duration of its lifetime. That means that internal clients will always return that IP address when they ask for that service. And that's very good because the DNS clients tend to hold and cache IP numbers. So they will not be exposed for different containers that comes and goes with their individual IP numbers. Instead, they will forward the request to the load balancer, and it will then forward it will request a load balancer for the service IP number, and the load balancer will forward the request to one of the currently running container instances. And for external clients, there is something called a routing mesh. And with that, you can allocate a dedicated port for a specific container service. And that port will be available in all nodes in the cluster. So whether to whatever node external request comes in, it will be routed to the service, and it will forward it to one of the container instances that runs for this service. So it's rather neat. So I tried that by setting up a 3-node cluster locally on VirtualBox. And then I performed the same test that for Netflix Eureka. But added to that, I tried out some resilience tests. So I killed some quote containers, and I even killed the whole node and verified that the orchestrator detected this and rescheduled containers to compensate for what I broke down. Thirdly, Kubernetes. Kubernetes has also a service concept that can be used in a very similar fashion to how the service concept works in Docker in swarm mode, actually. It can do more, but for now we simply note that it works. It can be set up to work very similar to the service concept in Docker swarm mode. So I tried that out, and this time I decided to go to the cloud. So I set up a Kubernetes cluster in Google Cloud, and then I also could enable autoscaling, both of pods, that's basically containers, and nodes for the Kubernetes cluster. And then I ran the same test as for Docker Swarm, but also tested verified autoscaling. And after putting some load on the quote services using the portal, I could see that Kubernetes started to launch new quote containers. And when I ran out of space in the available nodes, it also launched automatically new nodes to be able to launch even more containers or pods. So it also works very nicely. Last but not least, Amazon EC2 container services. Up until August last year, it was, to me, not very useful, actually. Sorry to say. But then in August, Amazon released something they call an application load balancer. It's an extension to their existing Elastic load balancer that comes with the capabilities to handling the dynamics of microservices landscape, where instances comes and goes, not something that the old Elastic load balancer not at all could cope with. So in this case, we run the load balancer outside of the cluster, outside of the EC2 instances, and it's actually Elastic load balancer instances that runs the application load balancer. So I set up an ECS cluster on Amazon together with an application load balancer, and tried it out in the same way as for Kubernetes, including the autoscaling. And it worked basically the same, except for how the application load balancer handles incoming requests. It differs a bit compared to the service concept in Docker Swarm mode and Kubernetes. It works more like an edge server. If you tried out Netflix Zool, you will recognize how it works. So what you have to do when you configure application load balancer is that you map the incoming URL in the request. You map the path of it to what service you want the application load balancer to forward the request. So as you can see, I have mapped a request that starts with API quote something to the quote service, and the other non-API related request is mapped to the portal service. So it's treated as a web page request. And besides that, it works quite similar to the other orchestrator, actually, from a service discovery perspective. Now, I've not had time to go into any details at all, but if you want to know more, we have a blog series on the subject, And we also occasionally perform workshops where you get a chance to start to develop microservices using the technology I've used for this trial. We had one yesterday, unfortunately, but we will have one in a month in Gothenburg on J-Days if you're interested and in Gothenburg at that time. Otherwise, I think it's time to summarize. I think my quest was accomplished, actually. I succeeded to deploy microservices in these 4 different environments without changing the code, only changing their configuration. Unfortunately, I don't have time to show it right now, but I can do it later on if anyone is interested. And it definitely proves that it prevents vendor lock-in. You don't have to write code specific for any specific environment. But at the same time, I could prove that I could use platform-specific capabilities such as auto-scaling. And I've used Java to implement this, but there is nothing that ties it to Java. This can be implemented in any language, actually. That's it. Do we have time for?
Yes, we have time for questions. Questions, anyone?
Yeah?
Yeah, speak it up and we repeat it.
Okay.
Question about more like infrastructural level. Like how you will deal with regions and zones, for example, in AWS, and dealing with Eureka in terms of discovery. Is it available through some sort of API that you can tell Eureka that part of the service is deployed in this region, some of the services deployed in that region, that kind of stuff? Have you experienced with this one?
Start to try to repeat your question. So it's about large-scale deployment of microservices cross regions. No, I have not tried that out. I know that Eureka or Netflix by itself have support for it, and I know Kubernetes have support for it, but I've not tried it out myself. Okay?
I have a question. So I know you didn't have time to go into that, but could you summarize it, or I assume that when you're addressing one of your dependent services that you're using is still a domain name. Would that be correct?
Sort of. I'm actually using a client library called Netflix Ribbon, which gives me possibility to use different configuration for different environments. So it's actually a more of a logical name that is resolved by Ribbon depending on the configuration, depending on the environment. Okay? Now I forgot to repeat the question, I realized.
The question was about how the client calls the service.
Yeah, so the question is about the resolution of service names from a client side. Yeah. Okay.
Okay. I guess no more questions then.
Okay.
So thank you, Magnus.
Thank you.